In this lesson, I'm going to show you how to make a prediction based on a known relationship. This question comes from College Board's MyAP for Physics 1. It says a small car with a mass m and a speed of 2v, and a large car with a mass of 2m and a speed of v, both travel at the same circular section of an unbanked road. If the frictional force required to keep the small car on the road without skidding is F, then the frictional force required to keep the large car on the road without skidding is one of the four answers. So based on the fact that we're looking at, or we're provided with the mass and the velocity of the car as well as the radius, and we want to figure out what the frictional force is, we're going to be looking at the formula Fc is equal to mv squared over r. So that is the formula that describes both the small and the large car. So I've identified the known relationship. And of course right here, that is going to be equal to the force of friction, which we're going to label as F. So now what we want to do is we want to take this known relationship and apply it to the small car and then apply it to the large car. So for the small car, what we'll do is we'll call that Fs, the force, the friction force acting on the small car to make it turn in a circle, is going to be equal to the mass of the small car, in this case the mass is m, times the velocity of the small car, which is 2v. So I'm going to have to put 2v and square that because the velocity is squared. And divide that by r. And in this case, the radius is the same for both, so we can just call that r. Now, what I'll do is I will expand this, and we'll say Fs is equal to 4, I'll move the 4 to the outside, mv squared over r. And that is the relationship that describes the small car in terms of its velocity and its mass. Now, the large car, we will do the same. The force required to keep the large car moving in a circle is going to be equal to its mass, which is 2m, its velocity squared, its velocity is v, so that's just v squared, divided by the radius, and again, the radius is the same in both cases. So here, nothing to simplify. So the next thing we want to do is we want to identify things that are constant or are the same in both cases. We see that the m is the same in both cases, the v is the same, and the r is the same. So this part right here that I'm circling, and this can be isolated. And that's what we want to do. We want to isolate what's the same in both vehicles. So what I'll do is I'll write this equation in terms of that constant value, and that's going to be equal to Fs divided by 4. And we'll do the same thing here. mv squared over r is going to be equal to Fl divided by 2. Now, since these two equations are equal to the same constant, what I can do is I can set the other side of each equation equal to the other. And that is the relationship between the small car and the large car. But we have to, of course, simplify this. So let's just do that over here. So that cancels, and that means that we want to figure out what is the frictional force for the large car. So the force on the large car is going to be the force on the small car divided by 2. And that corresponds to answer D.